In this video, we're going to get some hands-on time with Hive. We're going to use Hive to query our data, both from the command line and from the Hue interface. We'll use Hive to create, list, and delete tables. We'll use Hive to determine if a table is external or internal, and we'll discuss the important differences between those two. And we'll also drop internal and external tables and compare the results, as well as review some additional online labs and learning resources for Hive. Hive is a topic that is very deep and wide, and it pretty much encompasses all of the concerns that you would have around SQL. So if you're used to performing database operations with SQL, you'll be very comfortable with Hive. But you will need to go through and understand what the differences are. Hive does not support 100% of all the ANSI 92 SQL commands that you'd expect. On the required list, you better have been through the Hive Basics video, and you absolutely must have the Cloudera Quick Start VM or Cloudera Manager 4-node cluster installed. On the suggested list, you should have been through all of the MapReduce chapter, and you should set aside about 15 to 20 minutes total time to complete all the exercises. Hop over to your VM or your Cloudera Manager 4-node cluster. In this case, we're going to be using the VM. And let's do what we always do, pop a terminal, and let's actually pop a couple of them here. And let's go into Code and Data, Code, and Hive. And if you look inside of here, you are going to have a Hive exercises.txt file. Let's go ahead and do less on that file. Let's open our window up a bit. And you can see here that at the top we're talking about a sample page view dataset. This is a single CSV file. It only contains 4 rows. You could easily add additional rows, or you might even use some of your own data from your own organization to do this analysis. But basically it contains a Linux timestamp. This is an ID for a page. This is an actual URL that was hit. This is the referring URL. And then this is the referrer's IP address. You can see that all these individual fake page view data contains various data for somewhere else, Quick Cloud, and so forth. So the first thing we're going to do over here in our left-hand window is start up the Hive terminal. And again, this is a great reason to use Cloudera. Right off the bat, it has Hive installed as well as Pig, as well as Hue and all these other great things. So we simply need to start Hive. It's already installed. Next, we're going to create a database. Every table that we have in Hive needs to exist in a database. So we're going to paste this command over here, create a database called PageView. And actually it's saying that mine already exists because I did create this before. Yours should have just ran without saying that it existed. And next, we're going to copy this big ugly command. Before we paste this in, let's talk about it a little bit. The first thing you see that we're doing is creating something called an external table. And by telling Hive that this table is external, we're telling it that the data lives in some location in HDFS, and that Hive is not the only resource that will be interacting with this data. Again, if you are using Hive exclusively in your organization, you may want to create internal tables. And in that case, Hive simply moves all of the data into /user/hive/warehouse. And that's where the data lives. A huge difference between external tables and internal tables is that when you issue a drop statement on a table, if the table is external, it will not delete the underlying data. Those are really the big differences between the external tables and the internal tables. The interactions between both of them is almost exactly identical. The big difference is that when you issue a drop table statement on an external table, it will actually not delete the underlying data, because Hive is assuming that other folks need access to that data. So here we say that we're creating this table called PageView_external, so we can easily identify it. And we're creating several fields inside of here. A view time, we're specifying a type, an integer. A user ID could be a big integer. A page URL, which is our third column. In this case, quickcloud.com on the first result that we have there, and that is a string. A referrer URL, in this case google.com on that first line, which is another string, and then the IP address of the external user who hit our site, which is yet a third string because it has the dot delimiters between it. We can also add comments in our table definition. We're going to specify a row format delimited. This says that every piece of data that ends with a new line is a separate row of data. And we're going to say the individual fields are terminated by a comma character, as we see here in the middle. Hive, as well as Pig, I believe uses a *a character, a meta A character for the data separators. You can easily specify other field delimiters as you choose. And again, because we're issuing an external table creation, we're going to specify a location of where this data lives. And we've already loaded this in our subsequent exercises in user Cloudera input data page view. So let's go ahead and copy this command out, and let's run it in our Hive editor. And we let that rip, and we now have a table created. Again, we didn't need to actually do any MapReduce. This is just creating our metadata store, a place that maps when we ask for tables and fields and databases. We'll map that onto underlying data inside of here. So now we're going to go ahead and issue a describe command to see what this table looks like. And when we issue that at the Hive terminal, we see that we indeed have this view time, user ID, URL, and so forth. Important thing to note here, I did this intentionally. I put a view capital T time. When you create fields in Hive, if you issue them with a capital somewhere in the name, it will actually make it lowercase. So be careful of that. You probably just want to change that and have your actual field be view time all with lower. So that's one important thing to be aware of. That's great, just doing a page view external, but if we wanted to get a whole bunch of information about it, we can also do a describe extended. So let's try that over here. And when we issue a describe extended, we're going to get a whole lot more information. So we actually get create times, last access times, if we have any buckets or if we have any partitions set up as well, the serialization, deserialization that we're using. There's a whole lot of information in here. What we're going to focus on in this exercise is whether or not the table is internal or external. So if you're ever working on a new project and you're concerned that you might be working with an internal or external table, you can always issue this describe extended command on that table. And then look for the very last field you get back, the table type. And in this case, you can see that it's an external table that we're working with. So let's push the spacebar to browse down in our hivebasics.txt file. And let's go up a wee bit. Where were we? We were right here. So the next command we're going to run is this command, a select star from page view external. Because we've created that table, we would expect that to run. Let's push down arrow in our Hive terminal and paste it over here. And we expect a MapReduce job to run, right? And what actually happens is it returns right away. Why do you suppose that is? The truth is it has to do with this. When we're issuing a full dump of an individual table, it actually doesn't run MapReduce. It just goes and it basically does the equivalent of a Hadoop fs command and pulls the data back out. But here we can see that our data got entered back into Hive just fine, and our delimiters are set up as we expect. So our page view external table looks as we expect it to be. Let's now go in and run a query with a where clause. This will actually kick off a MapReduce job. So in this case, we're using this define table and a define field inside to issue a like statement. So maybe I'm only interested where the page URL is like my URL for my company. So I copy that out. And I'm going to go back over here. And when I paste it and I issue this command, it's actually now going to go ahead and kick off a MapReduce job. And just as we saw with the Hadoop jar command, we actually get a job ID, and we can go browse this through, and let's in fact actually do that. Go browse this through our job tracker web GUI, and we can go to localhost and 50030. And here we can see that our job is running, this job 0026, and this is somewhat interesting to note as well. The name of the job is actually a shortened down version of the name of the query that we ran. So this is a quick way to tell which queries in your system are possibly generated from Hive. And there is control facilities over this. We can specify an arbitrary name if we liked to our query, and then that would show up here. But instead, let's go ahead and hop in here and look at our map and reduce tasks. We see the exact same data. It looks for all intents and purposes exactly like a job that we submitted via the Hadoop jar command. And we would see the same results spit back into HDFS if we did not run it from the Hive command, if we redirected the output, say, to HDFS, or we were doing a insert overwrite file. That would actually put the data back into HDFS. But in this case, because we're running it from the command line, it just outputs the data back to the terminal. And you can see that we actually spent about 30 seconds to get this result set back. So although Hive does make this much more simple for us to interact with our data via SQL-like commands, it's still running MapReduce under the hood. And if you need really performant queries, you're going to want to look at Impala, which will accept a lot of the same queries that Hive will. So that's great. We just issued a very simple query where we did a like statement. Let's say that we only want to pull out specific fields where that page URL is like my URL. So we want to pull out a distinct page URL from that table where the page URL is like QuickCloud. And we want to see what that's going to generate. And again, a lot of these commands are just arbitrary, just to show you that we can do things like distinct group operations and so forth in Hive. And again, that's kicking off yet another job with a new job ID, and we would be able to go back and follow its progress and so forth. So that's great. We've been working with external tables, and that all seems to work fine. Let's actually go ahead and create an internal table. And I'm just going to copy this into my buffer, and then let's talk about this a little bit. Here you see that I did not issue a create external table. Here I just issued create table statement. And this actually is going to create what's known as an internal table. And again, I'm giving it this name. You don't have to obviously specify _internal at the end. I'm issuing a comment with this as well. And this time, not actually loading any data into it. So in this case, I'm literally just creating the table. And here you can see that our previous query had finally finished, and I did get the distinct that only had a single QuickCloud in there. So let's go ahead and issue our create table statement for our internal table. And we see that that comes back right away. Let's go ahead and do a describe on this as well. Page view internal, and see what we get back. Of course, we get back the fields we expect. And let's actually do an extended. Describe extended page view internal. And here we see now that the table type is a managed table. So this will tell us right away that we're working with a table that Hive thinks it owns. And when we issue that drop statement, it will actually delete the underlying data. So now that we have the table created, we actually need to load data into it. This becomes a two-step process with an internal table. So here we're saying that we're going to take the data in this HDFS path, and we're going to load it into page view internal. It's the exact same data that we loaded in our external table. And we copied that command. Let's paste it over here. And it's going to take a couple seconds to run. And now we actually have that data, and we can issue our select star statement. If we go back to here with an up arrow command until we see our select star from page view external, let's change this actually to internal. Again, it will not kick off an actual Hadoop MapReduce job. It actually just goes and pulls the data back out, just as we saw with page view external. So that's all fantastic. Where is our local data? Do you suppose it's still around when we did that load local data in path? Let's actually open a third terminal, and let's issue that command. So we copied it, and now we're going to see if that data still is in our local path. And indeed, it is there. We didn't delete the local data when we put it into an internal table. So we really now have two copies of the data, a local copy and a copy in HDFS. We just validated that the data did make it into Hive. That's the query we just ran. Let's look for where the data actually lives. So if we copy this out and we go back to our non-Hive terminal and we paste it, let's see if we actually have something at that location as we expected. And sure enough, when we issued that load data in path statement right here, load data local in path, it actually put the data up into user Hive warehouse, page view internal, the name of the table, and then the actual data. And if there was more than a single file, they would all be listed here. Again, you see that the Cloudera user is the one who issued that Hive statement to load that data, so they're the one that owns that data now. If we hop back over to our Hive basics file, we finish that command. Let's actually take a look at where our external data lives. So let's copy that. And again, in our non-Hive, our standard Linux terminal, let's see what else we have at user Hive warehouse. And sure enough, we do not have anything except our page view internal. And in fact, you probably will not see this. This was from a previous exercise I did. Exactly as we expected, our external data does not live at user Hive data warehouse. It actually lives at this location in HDFS. And if we copy that back out and we paste it in our Linux terminal, we can see that our pageview.csv is in fact still over here. and our external table is pointing to this directory. Every table that's created in Hive is exposed as a directory in HDFS, and then all the data files for that table are contained inside of that directory. So that's great. Let's hop over to our Hive Basics script and push spacebar again to drop to the bottom. We just ran this one. Let's actually do, again, a describe extended on page view internal. We're going to see exactly what we saw before. Again, we need to run this actually in our Hive terminal. And we see that this was, in fact, a managed table. And you can actually go through and run several other queries, and I would encourage you to do that. In fact, before we do these final drop table statements, let's hop over to a web browser outside of your VM, and you can just go to hive.apache.org. There's some great information in this set of documents provided by the Apache organization. The place we're going to start is actually on the language manual, and you can go through and see all of the various commands that you can run inside of Hive. You can run union, subqueries, you can do select and subselects in the from clause only. So you cannot yet do correlated subqueries, but you can do it in the from clause, and a whole bunch of other stuff. You can do joins, other things inside of here. I think there's some great exercises inside of this location, especially in the Getting Started guide, when you go through and you look at some of the example queries you can run and some of the example data sets. For example, you can pull down this Movie Lens user ratings table that they suggest here at the top of the URL in this Getting Started guide, and you can start actually running queries on this data. The Movie Lens data set is an open sourced set of data that contains various users' ratings of movies for various films throughout history. You can go through and run various queries to see what was maybe the most popular rated movie in a specific genre or by a specific user, and you can even actually do Mahout recommenders. There's a lot of information about the machine learning library Mahout out on the web, and this is one data set that they use. Before you delete all your data, you may want to actually crawl through some of the documentation that you have here at hive.apache.org. Again, either in the Getting Started guide or in the language manual are probably the two best places to start with what is possible inside of Hive. Again, we could probably have a full multi-day course on Hive alone. It's a very deep and wide topic. Back in our terminal, once you're done working with all of your data, you can then pick up and finish the very end of this exercise. So we're just going to take a final look at our tables. If you entered Movie Lens, you would see it here as well. We're going to issue these commands back to back, so we can just copy both of them and paste them both in our terminal. We're dropping the internal and the external tables. And when we issue show tables, we should see that both of those tables have disappeared. And sure enough, they're both gone. But back in our Linux terminal, let's go ahead and run these various commands. Let's first run this one on our internal table to see if our internal data is still there. And we certainly expect it to be gone. And sure enough, it's saying it is gone. And our external data, we expect to persist even after we issued that drop statement. So if we copy and paste that back in, we should see that this data is still there. So although we issued this drop table statement on an external table, the data persists after the table is dropped, versus on an internal table, the data is removed entirely. So let's go ahead and clean up our work here. You can just exit the Hive terminal with an exit statement, and you need to also issue a semicolon and exit out of this terminal. And that is the end of this script. So we can just push Q and exit out of this as well. So we now should have a clear understanding of how to use Hive to query our data, to create list and delete tables, determine if a table is internal or external, and then we were able to verify when we dropped internal and external tables and what the results were with our internal data being blown away and our external data persisting. We also now have a good picture of what additional online labs and learning resources are available to us.